The last subtopic of Chapter 6 is called 6.3 Partial Fractions. For partial fractions, there are 3 steps. The first step is to determine whether the partial fraction is proper or improper. So here, PF means partial fractions. If it is a proper partial fraction, you go straight to step 2. But if it is an improper partial fraction, you need to do long division. And this step is compulsory for improper partial fraction. So what's the meaning of proper and improper? Say that you have fx and gx. So look at gx. If the degree of gx is bigger than the degree of fx, therefore it is a proper fraction. Degree means the highest power of x. Say that you have x over x squared plus 1. So here the highest power is 1. Here the highest power is 2. So you can see that the highest power in gx is bigger than the highest power in fx. Therefore, this is a proper partial fraction. Now, what about improper? Say that you have fx and gx. So look at gx. If the degree of gx is less or equal to the degree of fx, therefore this is an improper partial fraction. Hence, it is compulsory for you to do long division. Say that you have x squared divided by x squared plus 1. So, the highest power for fx and gx is the same, which is 2. Therefore, this is an improper partial fraction. The same goes if you have x cubed plus 1 divided by x squared minus 1. So, here you can see that the highest power in fx is bigger than the highest power in gx. Therefore, this is also an improper partial fraction. The second step is to determine what kind of factors do we have in the gx or in the denominator. So, factorize gx completely and then determine what kind of factors do we have in the denominator gx. The first case is non-repeated linear factors. The second case is repeated linear factors. And the third case is quadratic factors that cannot be factorized. And the third step is to rewrite step 1 again. Case 1 is non-repeated linear factors. For example 6, we need to express the following in partial fractions. For step 1, we need to determine whether it is a proper or improper partial fraction. If it is improper, we need to do long division. The highest power in numerator is 1. But for denominator, if you try to expand it, you'll get x cubed. The easiest way is just to look at x, which is x times x times x. So that will give you x cubed. Therefore, the degree is 3. So you can see that the degree in denominator is bigger than degree in the numerator. So this is a proper partial fraction. So straightforward, you can go to step 2. Step 2 is your partial fractions. Factorize the denominator completely. So now this one has been factorized. So we just need to determine what kind of factors do we have. So we have x, x plus 1, x minus 2. So all of them are linear factors and they are not the same. So they are non-repeated linear factors. So here on the right hand side, we're gonna write them as fractions. So look at the factors. We have x. So write down something over x. And then we have x plus 1. So write down plus something divided by x plus 1. And then we have x minus 2. So write down something divided by x minus 2. So what do we need to put in denominator here? For non-repeated linear factors, just put constant in each spaces here. So I'm gonna put constant A, constant B, constant C. For non-repeated linear, always put constant only. Now you need to eliminate your denominator. Therefore, multiply everything with x, x plus 1, x minus 2. For the first fraction here, when you times it with this one, you can see that all the factors disappeared. So just multiply each fraction with x, x plus 1, and x minus 2. And we'll get this equation. So now we need to do substitution. Note that we have three unknowns, which are A, B, and C. Therefore, we need three values of x. It is compulsory for you to use the values of x that comes from your denominator. So just imagine everything here is equal to 0. So that will give you x equal to 0. This one will give you x equal to negative 1. And for this one, this will give you x equal to 2. So we have three unknowns and three values of x. So substitute all these three values into your equation. Let's start with x equal to 0. Note that this will give you 0, and this will also give you 0. So you're just left with negative 4 equal to negative 2a, and hence a is 2. Now let's do for x equal to negative 1. For the first term here, you can see that it is 0. And for the last term here, you can see that it is also equal to 0. Therefore, it is just negative 5 equal to 3b. And hence, b is negative 5 over 3. Do the same thing for x equal to 2. For the first term here, you can see that it is equal to 0. The same goes for the second term here, which is also equal to 0. And we are only left with negative 2 equal to 6c. And hence, c is negative 1 over 3. So we have found all the unknowns a, b, c. Let's do step 3, which is to rewrite step 1 again. So this is from step 1. A is 2. B is negative 5 over 3. And C is negative 1 over 3. So we must simplify our final answer. This one is okay. For the second term, bring denominator 3 to the denominator. And now you are left with plus minus 5. And that is simply negative 5. For the third term, you're gonna bring 3 to the denominator. Since we have plus and minus 1, that is actually negative 1. So this is the final answer of our question.